This video continues on a previous video looking at how air moves through an air handler and heat is either added or removed. In a previous video, we looked at the mixed air temperature section of the air handler. In that video, we looked at how an economizer can modulate the outside air damper and return air damper to try and match the mixed air temperature to the desired discharge air temperature minus the fan heat. When the economizer can't do all the cooling needed, heat is removed from the air by the chilled water coil. In this example, we're going to assume that the mixed air temperature that is made from the economizer section is 75 degrees, and that the discharge air temperature before the fan heat should be 53 degrees. So that gives us a delta T of 22 degrees. The equation that we're going to use for this is 1.08 times CFM times delta T. So this is an equation where we just plug and play. So we have 1.08 times 15,000 CFM times delta T, which is 22 degrees. And we're going to say this condition exists for 10 hours a year to make it easy. So by multiplying by hours, we're going to be changing the 1.08 times CFM times delta T equation from giving us BTUs per hour to giving us BTUs, which is energy. So this gives us 3,564,000 BTUs. And that's how much cooling is occurring, how much heat is being removed from the equation. Now, this gives us the heat that's required to be removed, but it doesn't tell us how it's being removed. So we're going to look at 3 different efficiency ratings and how you can calculate what the energy input to this equation is. The first one we're going to look at is assuming that we have a COP on our chilled water side of 3.0. Now to do this calculation, we will take our 3,564,000 BTUs and we will divide it by 3.0. Now COP is energy in over energy out. And so it is BTUs on both the numerator and the denominator of the equation, so it's unitless. So we can just divide by 3.0, which gives us 1,188,000 BTUs in to get 3,564,000 BTUs out. Now, we're not interested in what our BTUs in. We're interested in what our kilowatt hours in. And so we need to use the conversion of 3,413 BTUs equals 1 kilowatt hour. So we're going to divide by 3,413 BTUs per kilowatt hour. These are going to cancel. And this is going to give us 348 kilowatt hours. Now suppose that instead of having the COP, we were given the EER. Now if you remember, the EER is not unitless. It is BTUs over watts. So we're going to say that our EER is 10.24. So in this, we want to go ahead and say 3,564,000 divided by 10.24 BTUs per watt. These will cancel. and that gives us 348,046 watts. Then we divide that by 1,000 watts per kilowatts. And I'm sorry, this is watt hours. Watt hours. The watt hours will cancel, and you will get 348 kilowatt hours. Pretty similar to what we saw in the previous way of calculating it. And so we can say that a COP is the same efficiency as an EER of 10.24. Now there's one more efficiency rating that will be given, and that's kW per ton. And so let's look at what we would do in order to do this by using kW per ton. So let's say our kW per ton is 1.17. We still have our 3,564,000 BTUs. But now we need to convert this to a unit that's in the kW per ton equation. So we can divide this by 12,000 BTUs per ton hour, because we're talking about energy, not power. The BTUs will cancel. This will give us 297 ton hours. And now we know our efficiency is 1.17 kW per ton. We can also change this power equation into an energy equation by saying it's 1.17 kilowatt hours per ton hour. So we're going to divide this by, we're going to multiply this by 1.17 kilowatt hours per ton hours. The ton hours will cancel, and we will get 347.5 or 348 kilowatt hours. And so again, we can say that a COP of 3 is the same as an EER of 10.24, which is also the same as a kW per ton of 1.17. So using this equation, we can see the energy that it will take to remove 22 degrees of heat at 15,000 CFM for 10 hours in this air handler.